Hello everyone, welcome to my channel Dr. Tapati's presentation. Myself Dr. Tapati Bhanjade. In my last video, I have started discussion on enzyme kinetics. In that video, I have discussed about what is enzyme kinetics, why do we study enzyme kinetics. I have discussed about the order of the reaction. Within order of the reaction, I have discussed what is the order of the reaction, expression of the rate of the reaction, and types of the order of the reaction. Today, in this video, I am going to discuss about the zero order reaction. You will know about expression of the zero order reaction, graphs of zero order reaction, half-life of zero order reaction, and I am going to solve few numerical problems on zero order reaction. Kindly stay with me till end of this video. I hope you will like it. Let's discuss about zero order reaction. Expression of the zero order reaction. If the rate of the reaction is independent of the concentration of the reactant or substrate, in that case it depends on zero power of the reactant, then it is said to be zero order reaction. Here, rate of the reaction does not change with time. It is constant throughout the reaction. In that case, the equation is given by rate of the concentration decrease is equal to minus ds by dt equal to K into substrate concentration and power of 0, as it is, therefore it is called zero order reaction, and the value will be only K, that is K equal to rate constant of the reaction. So when is the rate of the reaction is equal to the rate constant? Answer is, in case of zero order reaction, the rate of the reaction is equal to the rate constant, that is K. If we plot V versus S graph or velocity of the reaction versus substrate concentration graph, we will find a straight line with slope 0. Which means if we increase the substrate concentration, there will be no change in velocity, and therefore we are getting a straight line. According to the equation 1, that is rate of the zero order reaction is equal to minus ds by dt equal to K S power of 0, that is equal to K. We can write it as minus ds is equal to K dt. If we integrate both of the sides, we will get this value, where S0 is equal to the initial concentration of the reactant at time 0, whereas St is the concentration of the substrate at reaction time t. Or we can write this equation as St minus S0 is equal to minus Kt, or St is equal to S0 minus Kt. This is equation 2. Let's plot St versus T graph, where I already told that St means substrate concentration at time t. In that case, as I told you in my previous slide, that St is equal to S0 minus Kt, which is the equation 2. If you compare this equation with that of the straight line y equal to mx plus c, and if we plot St versus T graph, we will get a straight line with slope minus k. Slope is minus k and intercept is S0. That means initial concentration of the substrate. Let's know how we can calculate half-life of the zero order reaction. The time required for 50% reduction in the initial concentration of the reactant or substrate is called half-life. It is expressed as T half. So at T half, substrate concentration will be half of the initial substrate concentration. If we write equation 2 again, St is equal to S0 minus Kt. If we replace T with T half, we get half S0 equal to S0 minus K into T half. Here St is half of the initial substrate concentration. Hence, we can get the value of half-life, that is equal to 1 by 2K into initial substrate concentration. Therefore, half-life of the zero order reaction is dependent on both rate constant, that is K, and as well as initial concentration of the substrate, that is S0. Initial concentration of the substrate is S0. So half-life is dependent on both K and S, initial substrate concentration. But I told you that velocity of the reaction is not at all dependent on the concentration of the substrate. Or we can express rate constant as 1 by 2 T half into S0. And that case, unit of rate constant is concentration into time inverse, that is mole per liter per second. It is the unit of rate constant, that is K. These are three examples of zero order chemical reaction. First one is production of HCl from H2 and Cl2. In this case, rate is equal to K into H2 power of 0 and into Cl2 power of 0. In this case, H2 and Cl2 are substrates, but rate is not dependent on the concentration of those substrates. In this case, rate is equal to K because power of hydrogen and chlorine is 0. In the second case, decomposition of N2O to N2 plus half O2. In this case also, power of substrate is 0. Substrate here N2O. Therefore, rate is equal to K. In case of third case, it is the reaction for decomposition of ammonia gas on hot platinum surface. Decomposition from NH3 to NH3 to N2 plus 3H2. In this case, substrate or reactant is NH3. Hence, rate of the reaction is equal to K into NH3 power of 0. As power of NH3 is 0, so the rate of the reaction is only K. That is, these are the examples of zero order reaction, zero order chemical reaction. Let's know different properties of the zero order reaction in short. We found total 4 equations for zero order reaction. Already I have discussed those equations. First equation shows that minus ds by dt is equal to k into s power of 0, that is equal to k. K is rate constant. So we can conclude from this equation that the rate of the zero order reaction is always equal to the rate constant. Hence it is independent of substrate concentration, because in this equation we are not finding any value of S. Therefore we can say that rate of the reaction is independent of substrate concentration. According to the equation 2, if we plot final concentration of the substrate versus T graph, we will find a straight line with slope minus K and intercept initial concentration of the substrate. We can find T half or half-life of the zero order reaction by equation 3. T half is equal to 1 by K into initial substrate concentration, which is showing that half-life is proportional to the initial substrate concentration of the substrate. From equation 4, we can find the value of rate constant, that is K is equal to 1 by T half into initial substrate concentration. Therefore, unit of K is concentration per time, that is mole per liter per second. Now we will solve few problems associated with zero order reaction. Problem 1. State true or false. The order of the reaction can be 0, fractional, or integer, and it can always be determined experimentally. Yes, it is true. The order of the reaction can be 0, fractional, or integer, and it can always be determined by experiments. Unit of the rate constant of a zero order reaction is per liter per mole per second. Yes, it is also true. I already showed the equation of K is equal to one by 2 T half into S0, that is initial substrate concentration. So it is moles per liter per second. Statement is true. Which option is correct? A zero order reaction is one in which reactants do not react. One of the reactants is in large excess, whose rate does not change with time, or whose rate increases with time. Yes, answer is C, option C, whose rate does not change with time. I have shown you that if we plot V versus T, that is T, V means velocity or rate of the reaction, V versus T in case of zero order reaction, we found this type of straight line where m is equal to 0. Slope is 0. So from that case, from this picture or this graph, we can conclude that in case of zero order reaction, rate does not change with time. In a zero order reaction, 50% of a substrate get converted to product in 10 minutes. What fraction of the substrate would react in 20 minutes? Let's try it for the solution. We knew this is equation 2 for zero order reaction, where St is equal to S0 minus Kt. St is final concentration of the substrate, S0 is initial concentration of the substrate, K is rate constant, and T is time. And from equation 4 we found that K is equal to 1 by 2 T half, that is half-life of the substrate, half-life of the reaction, and into initial substrate concentration. In this process T half value is given, that is 10 minutes. T half value is given, it is 10 minutes. We have to find out when T is equal to 20, what is the concentration of substrate, that is S T is equal to what? We have to find out it. If we put K value in this equation, we will find that St is equal to S0 minus 1 by T half into S0 and into T, that is equal to S0 minus 1 by 2 into 10, because T half value is 10, into S0 into 20, T value is 20. If you find out it, you can calculate this way. 20 will be divided by 20, that is 1. So S0 minus S0 is equal to 0. Therefore, the value of St is 0. After 20 minutes of reaction, concentration of the substrate is 0. So we can conclude that reaction is completed on 20 minutes. If initial concentration of a substrate is 0.1 m and rate constant of a zero order reaction is 0.003 mole per liter per second, concentration of the substrate is 0.075 m, 0.075 molar at time t. What is the value of T? Let's try it. For a zero order reaction, we found that St is equal to S0 minus Kt. That was equation 2. For this equation, from this equation we can write that T is equal to 1 by K within the bracket initial substrate concentration minus final substrate concentration at T. In this question, we know value of K, that is 0.003. We know value of S0, that is 0.1, and value of St, that is 0.005.
0.075. So you can write in this way, T is equal to 1 by 0.003 in the bracket 0.1 minus 0.075, that is equal to 1 by 0.003 into 0.025, that is equal to 25 by 3, and the answer is 8.3 second. So at 8.3 second, substrate concentration will be 0.075 molar. In an experiment with the initial concentration equal to 1.512 molar, St is 1.496 molar at time 30 seconds. Whereas in a separate experiment with the initial concentration S0 is equal to 2.584 molar, St is found to be 2.552 molar at time 1 minute. What is the order of the reaction? So in this case, we have to find out the order of the reaction. Let's try it. Rate of the reaction we can calculate as final concentration of the substrate minus initial concentration of the substrate divided by 2. So from experiment 1, rate of the reaction is equal to 1.496, that was St, and 1.512, that is S0, and divided by 30 second, that is the value of T. So that if you solve this problem, it will be minus 5.3 into 10 to the power minus 4 m per second. Whereas for experiment 2, rate of the reaction will be 2.552, that is the value of St, and 2.584, that is the value of S0, divided by 60. St, that this is St, this is S0, so St minus S0 divided by T. T is here 60 second, that means 1 minute. So it is equal to minus 5.3 into 10 to the power minus 4 molar per second. This is the this value is equal to, if you compare these two values, for experiment 1, this is also minus 5.3 into 10 to the power minus 4, and for experiment 2, the rate of the reaction is minus 5.3 into 10 to the power minus 4. So as the rates are same, it only happens in zero order reaction. Already I told that rate of the reaction of zero order is constant.
Thank you very much for watching this video. In my next video, I am going to discuss about the first order reaction. So don't forget to subscribe this channel and press the bell icon to get the notification.